Hello all, we are starting the presentation of the integration of Altium Designer and SAP. The two environments are connected by our next generation environments provide data in SAP and to upload BOMs. Additionally, we can manage the synchronization between Altium Component Library and SAP manufacturing parts. We can also manage the transfer of files used in the fabrication and manufacturing process. The operation with Integrate is started with a convenient drop-down menu, which is built into the Altium menu bar. Here the user has access to 9 functional modules or processes. Integrate2 is started very early in the design cycle, with the creation of a new Altium design project. Why do we want to build a new project within Integrate2 rather than in Altium? The main reason is that it allows central management of predefined templates. The templates can include schematic data, physical design data in masterboards, and output job files for manufacture. Thus, templates can save time and money and build consistency across the organization. There can be several sources from which to create a project. There are actually 4 options. The first source is a PLM template which is located in SAP. It is very convenient for the organization because the templates can be version controlled. The next option is an existing design which has been checked into PLM. You can also select a design which exists on the file system. And the last option is to use a template which is stored on the file system. It can be on the network drive or in a local file system. Let's take a look at this latest option. Why do we have 2 template selections? One template selection is for schematic. It is usually a drawn frame of a specified size. And secondly, the masterboard is the base PCB technology. This can be 2, 4, 6 or 8 layer board. So I'm entering the project name which we want to use, video 1 in this case, and I'm then pressing OK. And the project will be created in the target directory specified. When the design is fetched, it is automatically unpacked and opened within Altium. We now have our new project. As previously mentioned, for our demo, our template has some design and manufacturing data already included. So let's see what we have as a starting point for our new design. Here in Altium, for the design, we select Variants. And here we see in the variant window that we have 2 assembly variants with slightly different component sets. We have some schematic data with a drawing frame. We also have a PCB physical design representation. And here we have a link to our database or component library. We also see here that we have an output job file which defines which output jobs have to be created for manufacturing. These relate to a specific board technology. In summary, we have taken an existing checked-in design which can be used as a starting point for a new product design. All the schematic, physical PCB and manufacturing information is already available. Now let's look at the functional module which creates all of the data in PLM. On the pull-down menu we have a module called Save, or sometimes referred to as Design Push. Here we are in the Design Push window. The window gives you a way to store design data, to upload BOMs and to transfer manufacturing data. Depending on your workflow, you can either create items one by one, if the design engineer does not have full permission to create all items in SAP. Alternatively, we can select Upload All on the mid-left here in order to create all possible items and to set all checkboxes. So here we have all possible items checked. So this operation creates a data model, and we can review this data model later on. For now, we just mention the following documents which are created ready for save into PLM. First of all, we have an innovation document. This is a zipped folder which stores all of the design information. We also have a PCB part which represents our bare board, and a PCB document which includes documentation needed to manufacture the bare board. The files included here are Gerber files, drill plots, maybe a panel plot, and so on. We have two assemblies because we have two variants. Each of the assembly parts will have its own BOM. Additionally, our assembled parts is linked to the document which is used for the creation of assembled boards. Typically, this is a pick-and-place file and an assembly plot. There is also a possibility to assign some properties to your bare board. We have bare board dimension, board thickness, board material, and so on. This data will also be included in our manufacturing container in the form of a README file for the board manufacturer. Now we have all of the items and documents created, and I'm clicking OK to create a data model and to upload all of the data into SAP. Here the data model is being updated. Integrate extracts plot files and Gerber files using Altium out job files. That's why Integrate requires the out job to come from templates, because it's much easier to include all the procedures from the very beginning. Additionally, if some adjustments are needed to be done to the manufacturing files, they can be done in a convenient way for the design engineer by adjusting settings in the out job files, and Integrate will use these settings. Now when the links are actually created, Integrate creates a schematic plot file which is valid for both variants. It will also produce a variant-specific plot file and a variant-specific schematic file. Now uploads the design data to SAP as highlighted by the check-in messages at the bottom of the execution report. Now Integrate has extracted the BOM out of Altium Designer, and it searches for manufacturing parts from Altium in SAP. And it shows a BOM comparison report. Let's have a look at this. We will expand the window, and we have a BOM comparison for two variants at once. At the first position, we have our PCB item. Then we have a full list of components. In order to improve the analysis, we have several useful views of the BOM comparison. The first one is the reference designator view. There is one position or row per reference designator. Secondly, we have the quantity view. It shows the quantity of each of the component part numbers. The third view is missing parts. These are parts which are created in the design but which do not exist in PLM. Typically this might be a problem, but in this demo we will just skip any warning messages. The next report is unreleased parts. This is a list of parts which are not yet released, which are in a development state, or maybe they are obsolete. Unassigned parts view is a list of parts which do not have any part numbers assigned. And the final view shows a list of parts which are shared between the electronic and mechanical departments. In this project, this is just our bare board. I am confirming that the comparison port is OK, and there is a validation warning showing that some parts are missing. We will confirm that we wish to proceed, and now the BOM will be uploaded to SAP. And now Integrate checks in assembly files like schematic and variant plots and pick-and-place files. Now let's review the data that was created during the save module. We start with the design parameters that were updated during the save operation. There are configurable parameters which can be set during the project. For now, we show the ID of the innovation container. We also have the number of the PCB part, as well as several other parameters. If we now go to the schematic and look inside the drawing frame, we can see that these parameters are actually written into the drawing frame. All plots like schematics and PCB would have these numbers generated automatically. Now let's look at what has been created in SAP, and for convenience we will invoke a save functional module which will open the SAP client. So here we are connecting to SAP. Here I'm selecting one of the variants and pressing the Show button. This button starts the SAP client. We will go to the product structure and see what the product structure is. Our assembly is linked to two documents. The first is an innovation container, and the second is an assembly document. It also has a bill of materials which lists all parts. And the first part is a PCB. This is internally linked to two documents. One is an innovation document and the other is a PCB assembly document. We can now look at our BOM in more detail. We have the PCB on the first position. Then we have a list of components here. Integrate also maintains sub-positions. If we look at a specific BOM line for sub-items, we can see a number of reference designators in the sub-items table. Now let's go and look for documents that we have created. In our innovation document, we have a common schematic plot and an innovation container that stores the design data. We will open the schematic plot file to check what exists there. We have here our 2 pages with metadata added. And in the innovation container, we have all the design information. Now let's go to the variant document. In the assembly document, we have a variant schematic plot, which is variant specific. We have a variant assembly plot and assembly data, including a pick-and-place file, which we can display. The pick-and-place file is inside the container. We can also display the variant assembly plot. We use that inside the plot. We have the ID and the name of the PCB item. The metadata here is very configurable. We can display the variant schematic plot. We can see here that the variant component is crossed out. This is exactly the same as it would appear in the Altium environment for an assembly variation. The last document we will look at is the PCB document. In here we have the drill plot and the Gerber file. We can examine these in more detail. Let's have a look at the drill plot. And secondly, we can see all of the Gerber files here. Now we can go back to our push module. We have now reviewed many of the files which have been created in SAP by our integrate2 software. We are now going to the functional module, which automates the process of checking and synchronizing large volumes of information between an ECAD system and SAP. Synchronize Parts is the most configurable module and is adaptable to the customer's environment and workflow definitions. This includes issues such as who creates a new part, who approves it for use in production, and who manages the component obsolescence, and so on. In Altium, we also support Altium schematic libraries and database libraries. In this demonstration, we will show operations using an Altium database library, and the workflow will be to create a new part in the Altium database library and then to synchronize this to SAP. So we are simply going to create a new component in the Altium database library. I'm going to be creating a new capacitor. For the new component, we will assign a part number, video in this case, plus a description. We will use the type 2 field to make a link to the schematic symbol. We specify the manufacturing part number. Now the part is being created in the library, and I will start the functional module called Synchronize Parts. We are now in the Synchronize Part window. To select a part, we can either select a component via the class selection dialog, or alternatively, because we know the part number, we can use the quick search function. Here we search for the component video. We have found one component. In the overview window, the component is colored green because it is a new component which has not yet been synchronized. We select this and invoke Synchronize. After a short while, we will get some synchronization information. You can see that the part number was assigned. We can also open the component in SAP. For the new material 2847, we can see the description and the material. Also, additional properties could have been configured with other information to be transferred or synchronized. We could have manufacturer, for example, or electronic properties like tolerance and voltage. Now we could use the newly created component in our design. The part has been synchronized with SAP. The component can now be placed in the design and added to a revised bill of materials. We find the capacitor component, video 1, and then we will place the new part on the actual schematic. Under Properties, we can look at the parameters to see that the properties are synchronized with SAP. Here we have PLM part number, manufacturing part number, and so on. Then in Altium, we will need to run annotation to assign a reference designator to the new part. Okay, so our part has a reference designator or unique identifier in the Altium parts list. We can now run the Save module to save the updated design with a new component. We are now back in Integrate's Design Push window. We can check these two boxes to confirm that we want bombs generated for both variants. The same process continues and Integrate updates the data model and then loads the BOM from the updated design and compares this new BOM to PLM. We will of course generate a BOM comparison report. So in the reference designator view, we see that the part with the part number from SAP is now new in the BOM. And it has been added to both variants. We click OK in order to upload the changes to SAP. Now after the execution of the Save module in archive mode, our design is erased from the file system and the active document is released to SAP PLM. What if we want to continue to work on a design to create a new version? For that we have a module called Checkout. It's the third option on the pull-down menu. Here we are in the Integration Redesign window. From here we fetch the latest version of the design. We can also increase the revision number of the document in SAP if necessary. In order to check out a specific design project, we can either search by ID or by name. In the name search, wildcard characters are supported. So Integrate connects with SAP and searches for the innovation container which holds our design. Okay, this is our document and the checkered flag indicates that the document is released. When I select this document, the name of the relevant innovation container is automatically shown below. I am selecting this container to be checked out into the Altium target directory and checking OK. There is a warning message or message that the new revision will be created. We will confirm this. Now the design is being uploaded from SAP and will be automatically opened in Altium. Now when the design is checked out, we can go to the project options and we can see that the revision of the innovation container is now 03. So it has been automatically increased. Now the designer is ready to work on his checked out design.